In chemistry, we use a lot of formula, and two of them we know as empirical and molecular formula. Here the learning outcome. You are asked to define the term empirical and molecular formula. So after this learning, you can define the term empirical and molecular formula and then calculate using the data, and then perform calculation for reacting masses, volume of gases, and solution. Empirical formula is the formula of ratio of mole of element present in one molecule or formula unit of the compound. For example, you have hydrogen peroxide, the molecular formula is H2O2, then the empirical formula is HO because the ratio is 2 to 2. That's considered as 1 to 1. So the molecular formula H2O2 has the empirical formula HO. For molecular formula, that's the formula for the real number of atoms in the molecule. For example, you know the molecular formula of water is H2O. It means that in one molecule of water, there are 2 hydrogen atoms and 1 oxygen atoms. In hydrogen, the molecular formula is N2H2. Then this is the real number in one molecule of N2H2. Then the number of nitrogen atom is 2. And then the number of hydrogen is 2. Here are some examples of substances or compounds. Sulfur trioxide. The molecular formula SO3, then the ratio is 1 to 3. So the empirical formula is SO3 as well. For glucose, the molecular formula is C6H12O6. So the ratio is 1 to 2 to 1. So the empirical formula is CH2. For cyclohexane, the molecular formula is C6H6. So the empirical is CH because the ratio is 1 to 1. For butane, C4H10, that's the molecular formula, meaning that in one molecule of butane, there are 4 carbon atoms and 10 hydrogen atoms. So the empirical formula is 4 to 10, 2 to 5. So here H5. For ammonia, the molecular formula NH3. This is the simplest ratio. So the empirical formula the same as the molecular formula. Then we continue how to calculate the percentage by mass of an atom or element in a compound. Percentage by mass, AR times N over MR times 100%. N is mole of the element. For example, here, when we have substance iron 3 oxide, the molecular formula Fe2O3, then the percentage by mass of Fe is 2 times the AR of Fe over the MR of Fe2O3. So the MR is 2 times AR of Fe and 3 times AR of O. So we can multiply by 100%, we get 69.9%. If we want to find out the percentage of by mass of O, then we have 3 here, oxygen, so 3 times 16 over 3 times 16 plus 2 times 55.8, the same. So this one is the MR times 100%. Now again, when 1.55 grams of phosphorus P completely combusted plus O2, then oxide is a compound of an element with oxygen. So for P, then P and O. This the compound. The mass is 3.55 gram. Why increases? Because right now P plus oxygen to become compound. So the mass of P is 1.55, then the oxide here 3.55, so the rest is oxygen. Oxygen is 2.05. So we can calculate the N of P is 1.55 divided by AR. This is the AR of P. This is the N, mole. 0.05 mole. For oxygen, 2 actually here is 2 mass divided by AR of O, then we get 0.125 mole. Then we get the ratio, this one. How to find the whole raw number? Then these two number divided by the simplest. The simplest is this one. So the two numbers here divided by 0.05. Then you get the ratio 2 to 5. So the empirical formula is P2O5. For ionic compound, the bond is electrostatic, which very strong. So in ionic compound, the particle is not a molecule, but a giant composed by positively charged ions and negatively charged ions. So the formula for ionic compounds actually are empirical formula, or just the ratio of the positive ions and the negative ion. Here you have Na plus sodium ion, Ba2 plus barium ion, Al3 plus aluminium ion, K plus potassium ion, NH4 plus ammonium ion, Fe2 plus iron 2 ion, Fe3 plus iron 3 ion. Then you have an ion or negatively charged ion. This is positive cation, an ion negative. You have sulfate, SO4 2 minus, Cl minus chloride, BO43 minus phosphate, O2 minus oxide, Br minus bromide, and O3 minus nitrite, S2 minus sulfide. So, how to construct the compound formula? Here the charge is 1, minus 2, plus 1 and minus 2. To be neutral, then this must be 2. There are 2 sodium ions joined with sulfate ion, 2 minus, with ratio 2 to 1. The ratio number is 2 to 1. So the formula is Na2SO4. For barium plus 2, Cl minus 1. So must be 2 here. So the ratio is 1 to 2. So the formula is BaCl2. The name is barium chloride. Here I have given example for you. Then you do number 1 until number 10 in the same way.